Welcome to the AI for Career Success video overview by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. Now, this statement from Jensen Huang is really fundamental to understanding his method. If you want to grasp how Nvidia is architecting the future of AI, you have to look beyond the hardware. You need to examine the operating philosophy of its CEO, a vision that's engineered just as deliberately as any microchip. So, the insights we're going to explore today come from Jensen Huang's recent, very in-depth conversation with Lex Fridman on his podcast. This episode, which was published on June 29, 2024, really provides a masterclass in long-term strategic thinking.
You see, the entire Nvidia strategy really begins with a foundational problem. The reliable, predictable performance gains that we all got used to with Moore's Law were slowing down. At the same time, the computational problems of AI were just getting exponentially larger, way too vast to fit inside any single computer. A totally new path for scaling was needed.
Nvidia's solution is a concept that Huang calls extreme co-design. Instead of just optimizing one component at a time, the goal is to orchestrate performance gains across the entire technology stack all at once. It's a holistic approach where the data center itself is treated as one massive, integrated computer. The complexity of this approach is just immense. It requires world-class expertise not just in GPUs, but also in CPUs, memory, networking, power and cooling, and of course the software and algorithms that run on top of everything. All these completely different disciplines have to be engineered in perfect concert to get performance that scales far beyond what traditional methods could ever offer. And this whole philosophy of integrated design was really born from a pivotal, incredibly high-stakes gamble that ended up laying the groundwork for the entire AI revolution we see today, the decision to create and proliferate CUDA. See, Huang's decision was informed by a really key observation from computing history. Architecturally elegant designs, like RISC, often failed. Meanwhile, less revered architectures like x86 became completely dominant. The decisive factor, he realized, wasn't technical purity, it was the size of the install base. And this is the core logic right here. To build a successful platform, you first need developers. And to get developers, you have to offer them a large existing audience. This simple truth led Nvidia to a decision that was, well, as strategically brilliant as it was financially perilous. So what did they do? They decided to put CUDA on every single consumer GeForce GPU they made. This massively increased the cost of their core product with absolutely no immediate financial return. And the market reacted harshly, to say the least. It crushed the company's valuation. For nearly a decade, Nvidia endured this existential risk, all while betting on a long-term future that it seemed only they could see. Okay, so making bets like that requires more than just vision. It requires a specific methodology for bringing an entire ecosystem along with you. And this is where we can examine Huang's approach to leadership, which is fundamentally about building a shared belief in a future that he has already reasoned out. He doesn't just issue sudden mandates from on high. Instead, he systematically shapes the belief system of his employees, his partners, and the industry as a whole. He starts by reasoning from first principles. Then, he shares those insights gradually. Over years, he uses new data and engineering milestones to reinforce his vision so that by the time a major strategic shift is actually announced, it feels obvious and frankly inevitable to everyone involved. And all of this brings us to the culmination of these decades of strategy, the concept of the AI factory. This represents a fundamental transformation in the economic purpose of computing, a shift that Huang has been engineering toward for years. Think about it this way. In the past, computers acted as warehouses. They were cost centers for storing and retrieving information that already existed. But today, with generative AI, computers are becoming factories. They don't just store value. They generate new, valuable intelligence in the form of tokens. This transforms computing from an operational cost into a primary engine for revenue. The demand for these AI factories is driven by what Huang identifies as 4 evolving scaling laws. It starts with pre-training models on these massive internet-scale datasets. Then comes post-training, which increasingly uses synthetically generated data. After that, compute scales for test-time reasoning and planning. And finally, you get to the agentic era, where AIs multiply the workload. Each one of these stages requires exponentially more compute, reinforcing the need for ever more powerful factories. And this really brings us to the crucial takeaway. This shift from warehouse to factory, it's not just a technical change, it is a fundamental economic one. So the critical question for every professional to consider is this: If computing is no longer overhead, but a primary engine of revenue, what does the future of your own industry look like?
Thank you for watching. This is where we teach you AI and help you get smarter than your competition.
If you like these videos, please use the QR code at the beginning of this video to buy us a coffee, or hire us to coach you or your employees in AI. We also recommend you subscribe to the AI for Career Success YouTube channel and ask that you like, comment, and share to help us reach a wider audience.